Welcome to today's Learn at Lunchtime Artist Conversation from the State Museum of Pennsylvania. I'm Amy Hammond, Senior Curator and Art of the State Project Director. With us today is artist Marguerita Hagan, a ceramic sculptor based in Philadelphia, and an Art of the State 2024 finalist and award winner. Throughout her career, Hagan has brought to light the beauty and engineering of our planet's diverse ecosystems and our powerful role as stewards. Hagan earned a BFA in ceramics at James Madison University and an MFA from the Pennsylvania Academy of the Fine Arts. Her projects include collaborations with artists, scientists, and community, environmental art science residencies, and lectures. Her work is in private and public collections and exhibited nationally and internationally. Welcome, Marguerita, and thank you for joining us.
Hi.
Hi, thank you. As Margarita begins to share her screen, let me remind the audience that if anyone has a question during the presentation, please submit it using the Q&A box, and we will get to as many as we can after the presentation is complete. If you haven't had a chance to visit Art of the State 2024, the exhibition at the State Museum of Pennsylvania in person, there are still a couple of weeks left. The exhibition closes on Sunday, January 5th, 2025. And we are now accepting submissions for Art of the State 2025 through Friday, January 17th. And more information is available on the museum's webpage. And I see that Margarita has her presentation up and ready to go, so I will hand it over to her.
Hello. Thank you all for being here live and for those listening to the recording. I'm really grateful to the State Museum for hosting me, to Beth for manning the Zoom, and curator Amy Hammond for hosting this program, and for your great work at the museum and in the exhibit Art of the State. So the Flora Shield Trio is a tribute to our plant family who created our atmosphere as one of the key elements necessary for all life on Earth. This trio is part of my wildlife work, which includes flora, fauna, fungi, and La Mer. The wildlife series is inspired by nature's ingenious design, constantly perfecting for each unique environment. Yet, as we stand at the edge of this ecological precipice, the environment is telling us in no uncertain terms it cannot survive without our mutual support. We are in a time of epic shifts and are responsible for the positive changes needed now. The work intends to uplift awareness and wonder at this climacteric time on our planet, motivating wise, timely, sustainable investments for all life. We must live like our lives depend on it, because they do. The convex ceramic plays on the idea of a shield, defined as a person or thing providing protection from harm. It also heralds honor of and sense of family, like the countless species with which we share the planet. Like the focus of a lens, the shields and sculpture reflect our powerful role and reciprocal responsibility. So in preparation for this work, I did a lot of research, and imagine looking at life through the eyes of Flora on our planet. On the left page of my sketchbook, I created a timeline of life on Earth. And on the right, it's notes and drawings and design behind the 9 mini shields within this shield, representing different branches of the Flora family. These were also inspirations for me: the microorganisms, the tree of life, and also this Ruth Asawa sculpture. So life. In the spirit of a mandala and tree of life, the first Flora Shield life reaches above and below, straddling the realms of the seen and unseen. The mirror reflects the interior and ourselves as we peer inward. The exterior elements expand up and outward with the bow to thriving and abundance. Life celebrates 9 branches of the plant kingdom. It starts where all life began, at the microscopic level in the sea, to the most massive of all plants or any living organism, the mighty sequoia. From the center, the 9 mini shields within the shield spiral down and clockwise around to the outer rim. Elements from each section lead you to the next. Let's dive in. Water is life, and the sea is where it all began on our blue planet. The first undisputed fossil evidence of cyanobacteria and photosynthesis was 2.15 billion years ago. Today, the sunlit layer of the ocean photosynthesizes over 50% of all Earth's oxygen, but this was not the case when plants transitioned onto land. Here we'll start with phytoplankton. Plants began as the smallest flora and in the sea as phytoplankton that live inside one-cell jewels like this radiolarian. Hard to get the scale, but these are only visible in a microscope, with many in one drop of water. The exquisite microscopic silica or glass lace architecture was home to early plant life and still is today. The ocean photosynthesizes our every other breath. A deep bow to the mighty microgreens that started the world of flora. These microgreens are our largest living creature, the whales, source of greens, and all is connected, micro to macro. This slide right here shows the reflection of the radiolarian, the white lacy element, kind of just above center in that slide. So these are the drawings of radiolarians that were sparked by that sparked my Lemaire series by the 19th century artist, scientist, and philosopher Ernest Haeckel, who helped illuminate the world of nature. He gave us the word ecology, and you must see his Art Forms in Nature book that was published in 1899. Drawing from observation and the microscope then was the only way to share this information. I was really honored to be in the exhibit Invisible World of Water at the Academy of Natural Sciences. It featured his work and other 19th and 20th century pioneering scientists. I had 45 works in the exhibit, and my radiolarian shields were in the case with an early publication of Art Forms in Nature, open to the left image that sparked my Lemaire series. Here's a photo of radiolarians as seen in a microscope. They look like glass jewels. So although they're only one cell, the marine microorganisms in the sunlit layer of the ocean, they go macro when they bloom in spring, as caught in these stills from a satellite video. If microscopic organisms can create our atmosphere and fuel life on our blue planet, imagine what we can do when we're engaged and working together. Here we are with coral reefs. Warm, shallow coral reefs are both plant, the zooxanthella, and animal, the reef-building polyp. The plant is the microscopic dinoflagellate that provides nutrients powered by solar energy for the coral and lives within its cells. This pink and red coral gem is releasing her eggs. Brain and star corals, they spawn once a year by the full moon in late July and August. They know by the light from the moon to spawn. It's really incredible. This is looking at leaves, leaf engineering. When plants shifted from sea to land about 450 million years ago, they were a simple stalk with buds. They grew in numbers so that they exhausted the carbon dioxide levels and were starving. At this time, carbon dioxide was about 85 to 90%, with oxygen only 10 to 15% of Earth's atmosphere. They could not get their breath. So nature naturally engineered a brilliant design, the leaf. The individual leaves in this concave window create a lotus-like blossom below. The shield breath will give us a closer look at leaves. Flora did not make this transition alone, however. It could not have done it without fungi. Fungi began in water and colonized onto land about 460 million years ago. Its fine mycelium network is an essential communication system connecting and supporting flora in mutualism, which is infinitely affirmed in nature for eons. Merlin Sheldrake's The Entangled Life is a deep, poetic, and playful discovery of fungi and interdependence. Fungi's mycelium or fiber optic root system reached out to help the struggling first plants on terra firma. Fungi's the high-speed internet or wood wide web of the subterranean soil and a master collaborator. It has been working its magic for 1.5 billion years. So leaves created more surface area for plants to get their breath with built-in breathing portals or stomatas that take in carbon dioxide and release oxygen through photosynthesis within the plant. We're looking at a microscopic image on the underside of a wandering Jew leaf right here. Over millions of years, a diverse range of leaves continue to evolve and considered the late harvesting organs of vascular plants. Diversity is the key to success. It is essential that we get this memo, for together is how we can move forward as a planet. I love the work of Kristen Olson, who wrote The Soil Will Save Us, and her latest book, Sweet and Tooth and Claw, Stories of Generosity and Cooperation in the Natural World, is a beautiful bell to mutualism. Here's a look at grasses. About 100 million years ago, grasses appeared on Earth to defend against herbivores, dinosaurs. They drew silica from the soil and grew microscopic silica serrated leaves. Have you ever cut your finger on a blade of grass? This is why. And hence the silver luster daggers circling the peak into the cell, a cell of grass on my shield there. Most herbivore dinosaurs were not able to chew or digest the silica grass, so the grass challenger succeeded, while a few species did not. And the grasses really helped to shape the development of cow and horses, their gnashers, their teeth, so they could chew, and the complex digestive systems with multiple stomachs. Like everything, silica-rich manure eventually found its way to the sea, creating a bloom of silica diatoms, which developed about 200 million years ago at the end of the Jurassic period. Everything is connected. Here we're looking at cactus. The cactus on my shield is in the silver and gold. Cactus can live through extreme conditions and utilize water in life-saving ways. They provide homes and nourishment for insects, birds, humans, and animals. Their interior structure reminds me of the micromarine diatoms and radiolarians, and both have inspired architecture, art, and design. Frank Lloyd Wright found the saguaro a brilliant model. This lustrous silver and gold medallion in the shield is an homage to cactus's inner strength and design. My last visit to Joshua Tree was with a dear friend, and I photographed these bones of these cactus that were so beautiful. Here we are looking at the flowering family. The third eye of my shield takes us into the heart of a flower. The protruding rose-colored nodules are a microview of the papillae, a complex structure that is formed between the plasma membrane and the inside of the plant cell wall. These are from the petal of a rose. Papillae are projections from epidermal cells that form hierarchical structure on the surface of the rose petals. And the papillae and the rose petals are conical in shape. On the interior of my shield is a skirt of pink petals. Flowers are the reproductive design of the plant and often assisted by pollinating friends. Flowers are powerful in strategy, design, and aesthetic. a field, garden, or bouquet can magically uplift us with their beauty and many their fragrance. Different flowers represent different qualities and are a jewel of the plant family. Here are cones and seeds and sequoia. The most massive of all living organisms is the giant sequoia, and yet its winged seed is approximately less than a quarter of an inch. These are the copper-leafed little winged seeds on my ceramic. A symbol of realizing potential, this medallion honors the seed-bearing plants and the giants of them all. The interior has elements of the sequoia cone and flat copper stain with the migrating seeds and copper leaf. Incredible what can grow from a seed when nurtured, be it an intention, garden, or forest. Here's a look at moss and spores. This mysterious package magnifies the spore capsule of the flowerless moss and plays a crucial role in establishing new populations. The capsule contains up to millions of microscopic spores. When released, they travel with the wind, and when landing somewhere suitable, they grow into a new moss plant. Mosses were the first flora on land. On the lower right, it's a microscopic image of a lavender oil gland. Now we're going to take a look at aromatic and botanical oils. And this lower section here is the little shield for that. Here we are diving into a forest of trichomes. These are tiny tree-like elements and pearls of oil glands. So when we touch the leaves, we actually burst these micro oil glands, and so it's the oil that produces the fragrance. Fun to remember next time you run your fingers along a lavender, rosemary, or other aromatic botanicals and are graced with their fragrance. Here's the interior view of the shield life. A little bit closer look there. All of these are reflected in the mirror. And here's a shield light. Light plays on the alchemy of the photosynthesis process. Powerful golden photonic beams of light from the sun penetrate the plant and choreographs a chloroplast dance. These green bumps that are in a illustry, they really move all around. It's a very energetic process. The chloroplasts are in constant motion. And there on the upper left is an image of that. Here they are moving all around. And this is a petite light shield that I did as a dress rehearsal for this shield, working out colors and form and etc. The funnels, or these light harvesting complexes, take center stage here. The solar rays just come piercing through, and they split the water molecule into hydrogen for the plant, and they release the oxygen for our atmosphere. So it's a wild electric dance. Here's looking down into the petite shield, and you can see that light harvesting complex that I created. Here they are from a microscope with the sun going in with the light and splitting the molecule. So here's some details of my light shield and the lusters that I use to help kind of really express this electric energy of the alchemic process. The gold is energy from the sun, and the silver veins is the membrane, and the mother of pearl luster is across the chloroplast. So here's breath. Plants developed leaves after moving from the sea 400 to 450 million years ago as they struggled to get their breath. Leaves created more surface, and with it, their intake, and thanks to the aid of the microscopic portals or stomatas. Inhaling the essential carbon dioxide, plants exhaled oxygen, creating our atmosphere and breath. And so my abstraction was inspired by microscopic studies of stomatas from the underside of lavender and lilac leaves. And here are some images that guided me. It's so sculptural. It's like a whole nother environment. This is a diagram of a stomata, and it shows it opening and closing. And here's more stomata details that look so sculptural and velvety, like we're on a whole nother planet. This is some incredible patterns in a seen through the microscope that's like beaded with stomatas on the left, and a little micro forest here on the right with the stomatas. I believe that might be a lavender. So here's like a glass-like micro image of the underside of a leaf and my breath detail. So thank you very much. Happy to answer any questions.
Thank you very much, Margarita. That was a very, very interesting program. We do have some questions that have come in already.
Great. I'll stop sharing.
Yes, please. And we would love to see your video too. There you are. Okay.
Yeah.
The first question that came in is you have some pieces that look like pearls have been incorporated in them. Are they real?
Can you say that again? I have pieces that look like what incorporated?
Pearls have been incorporated in
Oh,
pearls. And are they real pearls?
um, thank you. Everything is ceramic. Um, I, it's how I finish them. Uh, white underglaze, clear glaze, and a mother pearl luster, so they do really look like pearls. And my piece went through probably about 7 different firings, and then I did post ceramic process work with the leaf, the the leafing and
Uh,
staining.
that kind of leads into another one of our questions, which has to do with some of your glazing. What types of glazing do you use? Because your colors seem to be so exact.
Thank you. I use underglazes for my color, and um most of I use an airbrush. I love the airbrush, and I've been working with it all of my career. That is enables me to do a very soft sensitive application or get even very super saturated color. And then I also hand paint, but it's the color is from the underglaze. And then I left say the Shield Life is flat color, but I highlighted with clear glaze over certain elements to give them the center stage and let them pop. The other shields, Life and Breath, they do have a clear glaze on all of them, but the color is from the underglaze. And this is earthenware process, so it's low fire.
And let's see, what makes earthenware such a great material to share your messages?
Oh, I've been working with it since my Japanese teacher, Misako Miyata, introduced it to me. Must have been about 19 years old. I can just I can go almost anywhere with this clay. It's at the lower temperature, it really stays. If you did some of the things I do in porcelain, they would be slumping in the kiln. So I just it is the best material to do a lot of the detailed and the delicate work that I'm really called to do for this work. Yeah.
And our next question has more to do with kind of your learning process. What came first for you, science or art?
Art, life. I think it's my love of life, and then finding an image or learning something and then needing to learn more. And then you find out that these one cell organisms that are glass lace housing phytoplankton created photosynthesize like our atmosphere. It's just it makes you just feel so in love and so grateful that it's really compelled me just to learn more and dive more. And And I didn't know about diatoms, but once you do, you just can't help but fall in love with them. As Cousteau says, people protect what they love. So um, we must all be falling in love and taking very good care of each other and our planet. But it's I am an artist, but I'm really in love with life, and I think that's how I got onto this adventure.
Great. I think our next question is referencing some of the drawings that you shared. I'm amazed at the centuries-old connection between art and nature. Do you see more opportunities for this in the future?
Oh, yes, absolutely. If you mean personally with my work, it is really kind of the heartbeat of my work. And I see it. We are in an incredible time right now. And there is so much great work, artwork being done, and incredible integration of art and science. Um, I'm in a residency right now at Penn with the Institute of Translational Medicine and Therapeutics. So I've been shadowing the interns that are paired, undergrads that are paired with the mentors at Penn. It's all about healing and using art as a voice to strengthen well-being and the community and diminish silos within the science. And I do believe everything is so connected, and it's really exciting when we can work together in different disciplines and people and nations and as a planet.
Yes, for sure. I have another question here that um, is kind of a process question for you. How do you begin your hand building, and what is the underlying structure of your sculptures?
Thank you for that question. I really love process. And if I was going to share about how I made these, it would be a whole different presentation. But these, I'll answer it specific to these pieces. So I start with a slab to make the shield, and I rest it inside these industrial walks, and in some cases, a gold mining pan. But I get the convex form, and then I get it into a state, and I start to build onto it, and cut it apart, open it up, add sections. The piece breath almost feels like puzzle pieces because, my God, those microscopic images of like lavender and lilac were so like so sculptural. It's really exciting to get to play around with all these different forms. Life, I wanted to open up, and I really spent so much, almost a good part of a year really reflecting and digging deep about how to do that piece called life. It's a lot to include so much into one piece. So I was able to find my way by breaking it into the little shields within the shield, and to present it in the spirit of a mandala or tree of life.
We have a comment here that the audience member loved the presentation and the way you showed the microscopic comparisons. And I was kind of wondering, what are some resources for some of the microscopic photographs that you shared?
Um, I just I listen, I read books, I listen to books, I watch things. There's a really great series, How to Grow a Planet on BBC. Um, it's fantastic. That's where I learned about the grasses. And Merlin Sheldrake's The Entangled Life. I listen to it because when I'm in the studio, I can't really be reading, but he reads it and it's in his voice. This is a brilliant book, and I've done a lot of research online and searching images and reading, but I had, even years before, I'd read about when plants came onto the planet from the sea, but they did not credit the fungi. And the fungi is is incredible. Their mycelium network reached out to help the flora get on land, and they are different species, but they are incredible. Like I said, master collaborators. Their work is vast, and he talks about that in The Entangled Life, which I really recommend. I really like Kristen Olson, and we have met in person and shared our work in parallel, but her work is great too. The Soil Will Save Us and Sweet and Tooth and Claw. But yeah, I just really keep searching and searching until I find the images and the information that really speaks to what I'm working on.
That those are all very valuable resources. I was wondering, we have a question here that is, what is the overall size of the piece life?
Of these pieces, um, they were listed in the let's see if I have that note in here. They are, I can tell you with my hands, but like they're about this big around. And the dimensions are on my website and at the museum. But I would say like 13 14 inches for life, something in that range.
I think that it's accurate, and I would say too that one of the pieces is displayed in the exhibition on a pedestal, and the other two are installed on the wall. So it's kind of an installation as a whole.
Yeah. What I really want, the mirror reflects the interior work, inner workings of life, the life of Flora. But it also, when the viewer looks in, you also will get to see yourself and our role as stewards of our planet and the reflection that we have. And I really encourage us all to be mindful of what kind of impact that we are going to be having on our planet and with each other. But yeah, there's a legend that I create with my complex work, and the life shield, you can see this legend on my website on the page, the Wildlife Shields, which is leads with this particular trio. So you can go and look at that later and see each little shield and the story behind each of those parts.
And we have a question here about what is next for you. What are you working on now, and what is inspiring you?
Oh, thank you so much. I actually I actually pulled something over here in case it just occurred to me maybe I might share what's happening next. But this is a piece that I just finished. I have a number of things going on, but this is a diatom shield that I've just finished that will be in an exhibit in Philadelphia called Close Encounters. It's going to be a show of my work and Greg Bralick's work at Box Spring that's curated and owned by Gabby Height, and that's in the Crane Arts Building. I'm also kind of on ongoing project with Dr. Eric Cordes on deep sea coral restoration, and have had his Cordes labs in the studio and did ceramic deep sea coral starts. These were deployed on September 8th. It was the day that the Art of the State opened. Amy, I got a text from Eric he was on the ship at sea, and they had just deployed the first ceramic coral starts in the Gulf of Mexico. He's been following the health of the Gulf since the Horizon explosion in 2010, and so much was wiped out. And what a lot of us aren't aware of, deep sea coral do not have plants in them, so they they weren't a part of this Flora Shield, but they really took, there's so much loss and a lot of oil still down there. And Eric's been following the health since that explosion, and we're doing some efforts to help get the coral back again. And they grow on their ancestors. So when like everybody gets wiped out, it takes a lot. Those things could have been just, you know, tens of thousands of years old. So we hope to be able to help some coral get started on there. That's something I'm working on. I'm also a current resident at Penn in the ITMET program and preparing for an exhibition. I engaged the young scientists to put art into their science, because I was there as a resident to put their science into my art. So I challenged the scientists to do this, and this is the first time that's happened. So there will be an exhibit of their work that will be announced soon in the spring of 2025. And they asked me to return for another year, and they want to make a documentary about the process with the scientist and the art. So I'm really excited about that.
Congratulations. That's exciting. I look forward to seeing that. We did have a question come in about your website, and I did put that in the chat. And I will also add that we will be sharing that information when we share the link to the presentation as well, so people can find it there. I think you may have answered another question that we had here, which was, do you have recommendations for places that I can connect with other artists focused on similar subject matter? But I think you just kind of touched on that.
Oh, yeah. Well, the Deep Sea Biology Society has opened just over a year ago, opened a chapter for artists. It's only been scientists, but now we're collaborating, and I would look into the Deep Sea Biology Society. You can see these things on some of these posts on my Instagram, or just look them up yourself. They have an artist page, and a lot of these are scientists that are artists, and they're working all over the world. And I have gosh, lots of friends that are doing this work, like Deirdre Murphy is based in Philadelphia. She's been following migratory patterns of birds and the effects of climate change. And Roberta Tucci, she has an exhibit up right now at Chimera Gallery in Philadelphia that's owned and curated by Angela McQuillan. There's quite a lot of artists working at the intersection of art and science and in environment. Kathy High I'm really honored to get to work with her on, she focuses on microbiomes in the gut, and we all have them, thankfully. But I did a trio of shields to put with her. They're in the museum in Lucerne, Switzerland right now, Musée de Le Mans. And that's also on my website. And I think there might be a link in the chat for that. But Kathy High is one of the pioneers of a Psi artist. So it's there's a lot going on. And once you get aware of things, you can discover what's out there.
That is very valuable to have all that information. Thank you. This is another process question. How long does it take in average for completing?
How long does it take an average for what?
For completing each piece.
Oh, I don't know. I really, sometimes they just come right through, and then sometimes I really have to really dig deep. Life took a long time, but I think sometimes when something is clear, I feel like when I can see it in my mind's eye, it's like 75, 80% finished for me. But Some pieces take months to work on. I feel like life was like that when it's kind of appropriate given its title. I also had a really dear friend of over 30 years that has followed my work all of my life. And as I was just starting that piece, wildly enough, she passed away very suddenly. And I was working on the piece called Life, and it just was very poignant. But it was also we were coming through the pandemic. And it just it feels like these every moment is so precious, and we're really blessed to be able to wake up every day and experience this life that we have. There are miracles all around us, especially within each other.
That is that is a great comment, and I have another comment here that I think is a great way to wrap up our Q&A. One of our attendees said that she would like to express her profound appreciation for you and your knowledge and talent. And she's a physician, and her perspective on life and living really resonates with me. Your work also bring back the days when she had to study microbiology and pathology. So it's a great comment to you and your work.
Thank you. Thank you so much. Appreciate that. I would like to leave everybody with the thought that we're just living in such historically epic times in a transition, individually and collectively, and that, like, say, looking into that life shield in the reflection of the flora, but also the wonder of flora is the wonder of you, and we're really powerful creators. And so I just want us to really energize what we love, because we experience what we put our focus on. And as things are so intense right now, I think it's even um, a really great and powerful time to focus on what we love and what we want to experience and create. Beyond it's think about the microorganisms that are in giving us our every other breath. They don't care what color we are, what race we are, what our gender is, where we live, our nations, our cultures, or who we love. They just keep powering and being of service for the planet, and regardless. And so it's really a great time for us to shift our perspectives so that we can shift our systems so that we can all really work together, because nature gives us such an incredible model. So we protect what we love, as Jacques Cousteau said. So I just say we should really, really fall in love, take care of each other.
Yes, thank you. Thank you so much to our audience and their wonderful questions. And thank you so much, Marguerita, for today's presentation. And again, we shared links for her website and her additional international work in the chat. We will also share it when we send out the recording. And please join us for more Learn at Lunchtime programs. Visit the State Museum of Pennsylvania's website at statemuseumpa.org for program information and to sign up. And thank you again, Marguerita. We appreciate your time.
Thank you. Thanks for everybody for being here. Thank you, Amy.